Hello, people.
Yo,
How are you, Fred?
I'm doing perfectly fine here in my Finnish uh, cabin setting. What about
Nice.
you?
I'm good as well. Fred is one of our rock star engineers. What is everyone saying on Twitter now? Cracked engineers on the lazy team. So we picked an interesting topic for everyone today. Um, Eval, especially with the new DeepSeek model that's been blowing everything up. So Fred, I'm gonna talk way less, but it would be cool if you guys, if you showed the people of the internet how we evaluate models at Lazy to make
Yep.
sure that when people send prompts, we actually write good code.
So let's do this. Let's see. All right, perfect. So when we do, when to check that the code that is produced by LLMs is actually quality code, we need to do a run a lot of checks. And at Lazy, we do this in the following way. We basically pick some a sample of what's going on by our amazing builders. And in this case, on my screen, I just have some settings saying let's pick something from 23rd of January, 100 builder requests from that day. And then what we do is we basically fetch those from our database and replay them against two sets of lazy that's running on our dev environment. One that is running our normal in production configuration that will produce a baseline set of results, and then another set of requests against a new set of new configuration and code, which produces a candidate set data set. And then we basically look at the difference in results from those. And in this particular, what's running right now is our baseline configuration has completed. In this um, in this run, we have the baseline doing things like uh, a particular way of using different models. Like we use a combination of Anthropic models and OpenAI models in a way that is pretty complex, but it's what we've found works best across lots of trial and error. It's basically a combination of 5 different models used in different kinds of retry loops and fallbacks, and for different contexts, for different reasons, and different prompts, and so on and so forth. And what we're doing here in the candidate configuration, we're trying to see if we can use DeepSeek's models to basically improve the quality of the code and hopefully also making things more cost effective. So that's the point of the DeepSeek model. So let's see if that works. Now we
Let,
may have
let,
to do
let
some.
me ask you a few questions to make sure that me and the audience understand correctly. So you're basically saying that we run an A/B test on replaying the prompts that our actual users send, and then
Yes,
we can change, let's say, one variable at a time. In this case, we have a chain of different LLMs that do different things along the way, and we're adding DeepSeek in front of that chain, or maybe switching out another model for DeepSeek, and then we run this on some sample of X to with the original configuration, the same sample with the new configuration, and then we compare the results. Is that right?
that is the right. That is a good framing of it. And we won't have the results for yet another. Let's see how it's going on here. It's been running about 59 out of 98 replayed requests on the candidate set, and it's saying it's going to take about 20 to 30 minutes left. And this is the first learning from running this eval, because even before we have the results, we see that the baseline here, scroll down, was actually, well, yeah, I actually ran this. Here we go. So we see that the whole set of 98 results finished in about 12 minutes. Ooh, something is going on. I think this means that DeepSeek is probably a lot slower than what we're using today. So that's initial results without even having the results on screen. We just see that this takes such a long time that it's and the only, as you said, the only variable we are changing here is the change to a DeepSeek model in one part of the code. So that is an early result, but we may need to do some magic editing here to get to a place where we actually have this
And
completed.
what platform are we using DeepSeek through?
Just their official DeepSeek API.
Got it. So we went directly to the DeepSeek API.
Yeah.
Can you share a little bit about the output results and basically what are the output metrics that we compare to know which model or which configuration produced the better results?
I can, but it would be much more impactful if I actually have the results in front of us. But
Okay.
we can talk about a high level. Like we have we structure these output metrics in different levels. This is why on the screen here we have some mentions of level 1 over here, and there's something we call level 0 at some other place here. It's actually just in the output of this cell, so we don't see it at this point. But basically we have level 0, level 1, level 2 metrics, where level 0 is basically is the response from the LLM working at all. That's one thing, of course. And then when it gets a response from the LLM, is it usable in our code? So one of the main challenges with working with code with the LLMs is that you're working with large file changes. So large files needs to have a few lines changed. Now you could try to just send all of that contents to the LLM and get the whole contents back. That's prone to error, not going to work, very expensive. So what we do instead is we ask it to this how like please tell us what to change and where, and then we change those lines of code. Sometimes though, not very often, the LLM will come back and be confused about what's actually supposed to change. And so one of the level 0 checks we have is just to check, can we apply these changes? And did the changes result in an actual sensible file? So if we can apply them and they're not completely broken, we go to the next level, level 1. We actually run a lot of linters and checks on the code. Like we look at imports look fine, and if there are syntax errors, there's like we just have like a bunch of checks at level 1, and so we get a list of code issues already at that point, and then we have basically a loop where we go through with more LM requests trying to resolve any new issues that cropped up. So that's the high level of just level 0 and 1. Now level 2 we don't measure in this notebook because that's basically the how it makes sense when you actually use it in the product, and we do manual checks for that after these complete. But this allows us to check that one, the model works, whatever, or the configuration, the new code, whatever we changed, it works at a basic level and it doesn't produce worse code than previously. And of course, we also check token usage, costs, time, all of these dimensions that will affect if we cannot stick with the change or modify it. So
Nice. So let me try to repeat that to make sure that I got it. So basically, you're saying that it's almost like a funnel of problems that we measure, besides things like how long did the request take to complete, how much it cost, and did we even get a response or not, basic things like that. We look at a funnel, and the funnel effectively produces the following result. At first, you're expecting the LLM to respond in some sort of a format, and that format needs to be applicable to the stack that we have that applies the changes to the code. So let's say you say, I want to build a new page. You're getting back the difference between the code of the application with the new page and without the new page. That difference is displayed in a certain, the response comes in a format from the LLM. If the format was correct, then you already know that's a good thing because you can at least try to apply it. So that's the first part of the funnel. Then after that, out of the ones that come back in the right format, we actually apply the changes to the code base. and then we look at a lot of automated code quality metrics to see if the code is good quality or not. But that still doesn't tell us if the feature is actually achieving, or the change is achieving the change that the user requested or not. And so that's the last part of the funnel. And we can measure across these three things. Is that roughly right?
And we do have like we can mention also that the next level, level two, the way we go about to actually measure that when you actually build apps with the model, like from start to finish. So what we have there, we have a sample of about, was it 200 now? Sample initial prompts that we basically run inside like an automated browser environment where we run our product, the latest product, to build this app and act as a user. So it will basically pretend to be a builder, a user that is building these apps. And then after it has tried to do it as much as possible in an automated way, we end up with either a successful application. We can see that from basic stuff like it's you can visit if it's a website app and so on, and there are screenshots. We navigate it. We have like random walks around the app. We check if there's any broken links, and everything that gets reported in the report to us. And then we do a sample of these 200 results to see like if they actually make sense. So we go in and say look manually at some of the histories and say this is a good result, like this is a good behavior that we want to promote, or no, this is like the LM or the system is taking the user in the wrong direction, or getting stuck on a loop or something. So yeah, basically those are the evals we have at this point. This is before launching any new changes.
Nice. Obviously, we've been making some videos about how our tool compares to some of the competitors in actually writing quality code. And I think this eval framework and the under the hood of what happens with each prompt and how it becomes a new app basically is the essence and the core of that system that allows us to compete in the market and actually produce real good results. So thanks for sharing that. I hope that was useful to everyone to know. It's one flavor of these evals. By the way, another interesting topic is right, that we look at the benchmarks all the time to figure out which models to try. But you can tell me if I'm wrong. But it feels that the benchmarks are well, there's as many answers as many benchmarks, and we had to build our own system to know the truth within the context of our environment. Would you say that's right?
Yeah. So what's happens is that some new model comes out. Some people get very excited. People like it on X, wherever, and then we go try the model for ourselves, and we find that it could be that it's not even available, or it's very highly rate limited, so we can't actually evaluate it at scale that we want to, or that it's very slow. Like maybe DeepSeek here is showing out to be too slow, that we can't accept that within the quality parameters that we have, or that for whatever reason it's a great model for simple math and coding tasks, but when you actually use real user prompts and requests with the model, it may be just performing much worse than what the benchmark suggests. So yeah, that's completely right, Peter. You have to be wary about the hype around specific models, and the only way to know is to run evals for it. And I can touch a little upon what you mentioned. It's like it's not only that we ask the LLM for code changes and then we apply them. Right? We have like a whole set of steps in between where we do. We prepare the code, we prepare the request from the user basically gets prepared in a certain way, and at one point, yes, we do request changes from the LLM, like what should we do here, and then we have another set of operations to actually apply those changes in a very fuzzy way, so that we can handle all the most of the hallucinations that the LLM will throw at us. We can get like higher performance metrics than should be possible just by assuming that the LLM response is makes sense. So there are like tons of sanity checks and modifications. and that's even before we're doing the level 0 eval. So it's like there's a lot of things going on under the hood. I guess that's just repeating what you said there, Peter.
Yeah, yeah. I mean, we basically we did choose a different path than a lot of our competitors in the sense that we don't allow you to code in any language and code exactly whatever you want. We're very good at Python, HTML, JavaScript frameworks, which are obviously the predominant way that people code today in the world. But part of the reason that we were able to get good at it is because we focused in, and we automatically fix a lot of the hallucinations that come along with these models and how they try to write code in these languages, right? So it's almost like we've written up a Bible internally on how to write Python, HTML, and JavaScript code that's applicable to the LLMs.
Yeah, and as you mentioned, like these are very we call these are core technologies that's been around for many years, which means that there's a lot of training data for the LLMs to be good at it. If you try to use most cutting edge frameworks, the LLMs won't just they would just not know what to do. But with the basics, does a great job, and that's why we're focusing on what the LLM's strengths are. I mean, we tried uh, adding some support and experimenting with other frameworks, and it just ends up being like a bad experience basically. But of course the LLMs will catch up, and so will, and when the LLMs are strong enough in certain areas, it's a good time to introduce new capabilities. But yeah, that has been a super clear. When you go to some other places, you try to build something using whatever authentication or some particular integration that the LLM may or may not know about, but it's not too much tutorials about it. It just doesn't know what to do. It will just return something like, now set this local host URL to your thing, and then you go to the site and configure it, blah blah blah. It doesn't understand the generic application of those concepts in an actual code base. It just maybe reads from a tutorial that somebody wrote 2 years ago. Yeah. Anyway, that's same thing that you're saying, and Peter.
I think our favorite example of that was always the asking the LLM, asking ChatGPT to write the code to use the ChatGPT API, right?
Yeah, that's great.
Completely, completely messing it up
But
and hallucinating.
yeah, when adding like prompt caching, it was really fun to ask O1 about it, like OpenAI's latest model, strongest model at this point. Like, there's no such thing as prompt caching, is basically the response. So unfortunately, you have to just pay the costs of all the tokens all the time. Like, come on, like, can't OpenAI models at least be like trained on their own documentation? Well, that's interesting enough, but that's the point. Like, you should stay with the tech, maybe at least a year or 2 years ago, for LLMs to do a great job. That's something we learned early on, at least.
Sounds good. Thank you, Fred, so much for your time and showing us this. This is really, really cool.
But now, like, I want to have these results. This is
We'll
so interesting.
we'll post them afterwards. I'm sure
All right,
everyone's excited
let's
to
see.
see DeepSeek on the real task rather than
Exactly. What's DeepSeek? This is DeepSeek Coder version 3, right? Sorry, DeepSeek Chat version 3. So what's DeepSeek Chat versus Haiku gonna show? Oh, that's very interesting. Interesting. Let's see. Okay. Anyway, I can't wait to see
See you
what's.
later, man. Thanks again.
Cheers, man. Ciao.